Hello, today we're going to practice some more binomial theorem application. These problems are on the OneNote below the ones we did in the previous video. So again, we want to focus on setting up our binomial, on making sure that we're looking at the wording properly and determining what's going to be most efficient here. So we've got a furniture company balloon contest. So we've got a free purchase or not a free purchase. So let's set that up as our binomial theorem or as our binomial. So we've got our options. So it's free or not free, like a regular purchase you pay money for. So 1 out of every 50 balloons contains the tag. So we can do this 1/50th, or you can make that as a decimal, which is 0.02. And then the not free is 49/50ths, or 0.98. We are raising that to the 14th because there are 14 purchases during the day of the sale. So we're looking for the probability that 2 or more of the purchases are free. So what we want to do here is we've got the probability that 0 are free, 1's free, 2's free, and so on up to the probability that all 14 are free. All of those probabilities have to add up to 1 because 100% of the time between 0 and 14 of the purchases will be free. So we're looking for 2 or more, so we're looking for this range of values. So the easiest thing to do then is subtract the probability of 0 and the probability of 1, winner, free purchase, from 1, from that 100%. So we want to do 1 minus the probability of 0 plus the probability of 1. And watch your parentheses when you're doing this. So set this up. The probability of 0 free ones, well, we've got our 14c something, 0.02 to some power, 0.98 to some power. And then the same thing for the probability of 1 free order. All right. So here, this one of probability of 0 free ones, well, that's 0.02 to the 0 because that's our free probability. And then that means it's 0.98 to the 14th. So this has to be 14 then, so it's 14C14. So when we're typing this in the calculator, this is 1, this is 1, so you just need to do 0.98 to the 14th. And then here, we're looking for 1 free purchase, so that means there are 13 not free purchases. And this will be 14C13, which is just 14. So we put this in the calculator, watch your parentheses, and just make sure that you're subtracting the proper things. So 1 minus in the parentheses, 14th plus 14 times 0.02 times 0.98 to the 13th. Close your parentheses. And there is a 0.031, or that's a 3.1% chance that 2 or more of the purchases are free. All right, so when you're looking at 2 or more, at maximum 2, at most 2, at least whatever, pay attention to the wording with it. Okay, so we've got this multiple choice question test here. So each of the choices A, B, C, and D is the correct answer 25% of the time. So randomly assign the correct answers to A, B, C, D. The probability that in the first 10 questions, A is the correct answer for 5 questions. So first thing we need to do, set up our binomial. So we've got A and then B, C, or D. So we have 1/4, or 0.25, plus 0.75, because quarter of the time it's going to be the correct answer is A, and then the other 3/4 of the time, the correct answer is going to be not A. So then we're raising that to the 10th power because we're looking in the first 10 questions. So if A is the correct answer for 5 questions, because it doesn't give a range or at least, at most, whatever, we're looking at just when A is the correct answer for 5. So we set this up. So we have 10C something, 0.25 to a power, 0.75 to a power. A is the correct answer for 5 questions, so it's 0.25 to the 5th, 0.75 to the 5th, 10C5, and then we multiply those 3 values together. So remember, in your calculator, the combination for doing 10C5 is in the math, under the math button in the probability menu, and then we're multiplying that by 0.25 to the 5th, and then multiplying that by 0.75 to the 5th, and that will give us 0.058. We're rounding to the nearest thousandth, so 5.8% of the time A is the correct answer for 5 questions. All right, so what we want to look at, so our board game, player must roll a 1 or a 2 on a die to attain a bonus. We're talking about this as a D6, so it has 6 sides. So in 5 rolls of fair die, what's the probability that they'll roll a 1 or a 2 at least once? So first thing we need to do, set up our binomial. And this is one where, for this specific problem, some people get thrown off with the 1 or a 2. So what's going on there? Just look at it as your 2 cases. We're splitting it into 2. We've got the chance you roll a 1 or a 2, and then the chance you don't roll a 1 or a 2, which is if you roll a 3 through a 6. So we've got 2 of our 6 options. So 1/3 of the time we'll roll a 1 or a 2, and then 2/3 of the time we'll roll a 3 through 6, or not a 1 or a 2. So at least once, we're rolling it 5 times. So we're raising it to the 5th power. And what we're doing here is at least once. So we can set up like the probability of 0 plus the probability of 1, and then so on until you get the probability that you roll 1 or 2 5 times. That's equal to 100% of the time that will happen. So between, what we're looking for is between probability of 1 and probability of 5 1s or 2s. So the most efficient way here is to just find 1, subtract the probability that there are 0 1s or 2s. Okay, so with this, we'll do 1 minus, and then it's 5, and then we've got 1/3, and then we've got 2/3. So 1/3 is to the 0 power because we're looking at the probability of 0 1s or 2s. So that means there are 5 not 1s or 2s. So that is being raised to the 5th power, and it's 5C5. So when we're typing this into the calculator, 5C5 is 1. 1/3 to the 0 is 1. So it's just 1 minus 2/3 to the 5th. And make sure that 2/3 is in parentheses with this. So we end up with 0.868. So 86.8% of the time, we are going to have at least 1 or 2. Okay, so for practice with this, I just want to, because the video is getting a little longer, just write out what you would do for this. So exactly 4 toys, you're just looking at the probability of 0. Or sorry, the probability that you have exactly 4 toys. No toys would be the probability of 0 toys. At least 1 toy, because you're looking at your different probabilities. You've got 0 toys, 1 toy, 2 toys, 3 toys, or 4 toys, and that's equal to 1. So for C and D, when you're looking for ranges with this, so at least 1 toy is all of this, because it's 1, 2, 3, or 4 toys, and you add those together. So you can just do 1 minus P0, which is your answer from part B. at least 2 toys is 2, 3, or 4. So you can do that as probability of 2 plus probability of 3 plus probability of 4, or you could do 1 minus probability of 0 plus the probability of 1. So either way, I like doing this one because it is more efficient. You're only doing 2, but if it works best for you, figuring out 2, 3, and 4, whatever works best for you. So I just want to talk about this one last one, just because this one's odd because it's some coin flipping. So coins tossed 7 times, sequence of heads and tails have no more than 2 heads. So when we set up our binomial, it's either heads or it's tails. Your probability is that half the time it's heads, half the time it's tails. We're raising that to the 7th power. So the thing is, when we write this out, so no more than 2 heads, so that's probability of the 0 heads plus the probability of 1 heads plus the probability of 2. So no more than 2 means we include 2 with that. So when we go and set this up, I want to write this out as probability of 0, probability of 1, and then the probability of 2. So what ends up happening here, we set up our binomial theorem the same way for all of these as we have the other ones. So we have 7c something. Okay. So if we're looking for 0 heads, well then this is 0, this is 7, so this is 7. Right? Because this first one's heads, the second one's tails. But what ends up happening with this is it doesn't really matter which order you do this in because they're the same. So what ends up happening, 7c7 is 1, 7c6 is 7, and then 7c5, I don't know what it is off the top of my head. But because we have like bases when we're multiplying these, we add the exponents. So all 3 of these terms are going to have a 0.5 to the 7th. So I want to factor that out. So what we're typing in the calculator is this. We can factor out a 0.5 to the 7th, and then what's left in there is 1 plus 7 plus 7c5. So when we put that in the calculator, we end up with a 0.227, or 22.7% of the time we will have no more than 2 heads. So it works, it's set up the same way, but it can work a little differently solving it if it's something where it's a 50-50 chance. Thanks for watching. Let me know if you have any questions.